Let's take a look at this problem where a graph f of x is given to us, and we are asked to sketch the derivative of this function, so f prime of x, on this entire interval from -4 to +4. So when we're getting going on this is the original function that's given to us. What we want to do is first identify wherever we have a maximum or a minimum, we're looking to have a horizontal tangent line at that point. So that means the tangent line is going to have a slope of 0. All right, since we're trying to draw the derivatives graph, we're looking for a slope of 0 means that at -1, where this minimum occurs, it's going to be 0 on the x-axis right here. A horizontal slope, a horizontal line has a slope of 0. So that's going to be one point that we're going to focus on this graph. And I'm kind of drawing this one in just to show that horizontal tangent line going on there. I'm going to clear that off before I draw in my graph of the derivative and submit this. All right, the next thing you want to do is we want to think slopes of tangent lines. The easy ones to pick out tend to be 1 and -1, although we can look at 2, I think, on this graph as well. So if I draw a -1 for a slope of a tangent line, that means go down 1 and to the right 1, down 1 to the right 1. It looks like we hit right here at an x value of -3. So at -3 on our derivatives graph, we're going to have this point at -1 was the slope of the tangent line. So that's going to be a second point on our graph. All right, so I'm going to include that point and draw my line to where we said we had a 0 slope, and it's going to look like that. All right, now I'm going to clear this off and draw that same line again. You're going to notice that if I submit this question, what's going to happen is it's going to not give me full credit. All right, so, okay, we don't get full credit. Now, why that is because we're trying to draw the entire derivative over this entire interval. So connect from side to side. All right, so it may be handy to find some more points that are going to be on our graph. Like over here, if I drew a horizontal tangent or a tangent line to the graph, it looks like it's going to be up 1 and to the right 1. That hits the graph right here at +1 for an x value. So another point on our graph could be right here. We could continue on this same action. All right, let me get rid of that. You can extend this by continuing to just go up to it and drag it. And that would include both directions as you're trying to get this nice graph. I'm going to have to redraw this because I have this other line right here. It needs to go away. This does seem to indicate that our derivative is supposed to be 2 at an x value of 3. Let's draw that in real quick. If I clear this all out, a slope, that looks like a tangent line at 3 to our graph. The slope of that line is going to be up 2 and to the right 1, or down 2 and to the left 1, which would be a +2 for the slope of this tangent line. All right, so let's put that all together. We said it was going to be 0 at -1, and then we said it was going to be -1 at -3. And then what I'm going to do is I'm going to drag this along, keep it a nice straight line, extend it all the way from one side to the other, and then we're going to submit our answer. All right, so you can see we got 1 of 1, which is exactly what we want on this one. Full credit, and we can move on to the next one. All right, hope this helps. Good luck to you.